Now you might be wondering, why is this story such a huge deal in terms of nuclear fusion compared to nuclear fission? And this is really fascinating because Forbes actually released an article that states that, hey, this is a ground changing, I would say, experience for scientists, something that have never been done before. And I was like, if that is the case, how is this so? And looking thoroughly at the article in terms of not only the history behind this particular type of energy production, potentially what experiment led to this, and most importantly how this is going to be tied really well to money and investors coming into this type of technology, is going to be mind-blowing in future. And this compared to when this particular technology was discovered around a century ago, and this discovery has led to some really turbulent times in understanding how to produce energy that is more than putting in that energy into the system. And so this article actually states that this is the first time that the amount of energy that is putting into this reaction is way less than that of the energy that is produced. There are so many benefits of this type of nuclear fusion technology, because one interesting thing about this is that it has little to no waste compared to nuclear fission. And nuclear fission, of course, is where you have an atom and you split it, and when you split it, this produces energy. Of course, this is similar to your nuclear reactor that powers specific locations around the world. However, the huge drawback is the amount of radiation that is produced and waste in this process, and it's really challenging to be able to manage and properly store those wastes concerning nuclear fission that we know from nuclear plants. However, for nuclear fusion, a shining example is our sun. Our sun uses hydrogen and brings them together to form other particles, and this is pretty much the essence of other creation that we have out of space. Now, the date to remember is December 5th, where this was performed at the National Ignition Facility, the Lawrence Livermore National Laboratory that is in California. The public announcement was made on December 13th, and so it's really remarkable to remember that, hey, this is pretty much the start of many big things to come when it comes to how this research was performed and what are the barriers that took place before heading to this new step in science exploration. Well, speaking of energy efficiency, now in terms of the source of nuclear fusion, the material that is used is readily available hydrogen atoms that we can find in seawater. However, this here is not possible for nuclear fission, because for nuclear fission we actually use dangerous radioactive materials that are really beneath the Earth's surface, and so that is one of the benefits of this particular fusion, because the materials are readily available for us and they are not radioactive. However, for nuclear fission, it is radioactive and not readily available for us. Now, the big question is, how were scientists able to make this huge change a really profitable result? What they did was that this facility, which is where the thermonuclear initial fusion facility, which is a process by which you're able to perform fusion, which is around this amount, which is like $3.5 billion, is really a huge laser complex. And this huge laser complex, what is like, is a cylinder where at both ends we have around 192 lasers that are shot into a capsule. Now, if you look at this capsule closely, inside it has hydrogen atoms, and these hydrogen atoms, when it's really hot, it vaporizes and immediately performs fusion. And so what results in this is that, hey, we can be able to generate larger atoms in this capsule. Now, the drawbacks of this was that, looking at the capsule, the walls were thin, and this increased the number of flaws that will inhibit the experiment to produce more energy than the amount of energy that is coming from the laser, which is way greater. Therefore, enough for them to overcome that challenge, what they did was something quite simple but remarkable. They had to thicken the capsule walls, for the floors to be less for this experiment. Now, looking at the effect of the fusion, when the 192 lasers are shot at the capsule, initially these X-rays impact the capsule walls. Therefore, this prevents the fusion fuel from being able to be hot for substantial amount of time and therefore perform the process of ignition. But then what happened is that they had to change the lining of the capsule walls in such a way that when the lasers are shot at it, the amount of heat that is absorbed by the fuel is pretty much symmetrical in such a way that the fuel is able to slowly be heated up and therefore perform ignition. Therefore, this is really a wonderful strategy compared to either changing the type of material that is around the capsule, which is spherical, or changing the shape of the capsule, or increasing the number of lasers shot at the capsule. And this little change of the capsule walls in terms of the thickness, increasing it makes a huge difference, and the difference is shown by how much energy is produced compared to how much energy was put in. Now, the amount of energy that was put in was about 2 megajoules, but then guess how much was released? 3 megajoules, and this is roughly around a net amount of energy to be 1.5, which is a great start for many things to come. So I'm really curious to see how next innovations will improve on that number, because right now we are now at the positive zone, and being at the positive zone for science means a big deal in terms of how much we can actually harness from this process. And I'm really curious, I'm excited to see how this is going to be followed up by generations of scientists, physicists, and also how this will change our understanding about nuclear fission, like for example for our sun, and those kind of studies from outer space, how we can replicate these, for we to produce renewable, wonderful resources, for we to limit the amount of waste that is produced and also be more efficient in the production of energy. Now, in terms of the benefit, there are numerous amount of benefits that are associated with nuclear fusion, either in terms of the emission of carbon dioxide. This is really important because, hey, we have to limit that footprint. So in terms of the many ways by which we are producing energy in terms of fossil fuel and coal, now using fusion is going to be going from a lot of carbon dioxide emission to pretty much zero, and that means everything changes. The speed of innovation, the speed of production, efficiency of various products is going to change drastically, and this is very amazing to just watch that over time. And I'm really excited to see how things are going to improve, hopefully, if the right investors and investment and money are put into this potential energy that is at the primary stage. And so I'm really excited also to see how this is going to improve our way of life, and also how we're able to manage and recycle other products. And this is going to be interesting to see how generations to come are going to improve on this technology, not only from the big grand scale of things, but also at the little things that we do in our houses, like for example the use of our laptops or electric cars or various battery using technology or devices. This is going to be a huge step in terms of how efficient our lives will be run. Now, one thing that we need to keep in mind is how far to the future are we going to be approaching for this particular type of technology to be achieved. I mean, if this took us around 40 or 50 years, for we to go from those challenges to where we're at now in terms of positive energy production, this is going to take us a little longer time. Definitely not 2-3 years, absolutely not. It's going to be a little bit more that decades, and this requires a lot of patience, time, and investment into this technology, improving the efficiency of the lasers that are being used, and these are various things that we need to be thinking about in terms of investment into this technology. And so this has actually happened before. When you're looking at other types of technology like space exploration, the government didn't have that much money, and so they're like, you know what, should we shut this down or put it for commercial? And that is where we have various interests springing up of various innovations in space exploration. And so saying this, will the taxpayers be able to buy into this particular investment that the government is going to put in, or is the government going to outsource this technology to other big financial institutions to be able to invest into this technology, so that as time goes on there will be better innovations that will be put in here, and by so doing we are going to actually get this particular timeline from just something that is 40 years away or 50 years away to something actually close to reality, to our generation, maybe 25 or 15 years from now. So this is really interesting to see how decisions are going to be made, is going to galvanize this technology and push for it, just like how we did back in the days with that of nuclear reactors, but that didn't pan out because of the huge waste and disaster and the negative impact outweighing the benefit of that technology. So this here seems to be in the opposite direction, and this opposite direction might lure investors to actually have a more open heart into putting in money and resources into these technologies, which is more of a futuristic, cleaner approach. So overall, let's know your thought about this particular result in the comment section down below, about the fascinating breakthrough of nuclear fusion and how this is going to change our lives, hopefully forever, if the right amount of investment, the right amount of time, and the right amount of patience is put into this technology. And let's know your thought about what are the alternative ways that they can improve on this technology and modify various sections in this reactor or in this particular space facility in order for we to produce a even more positive net energy production in this system. And let's know your thought about this in the comment section down below. The links to this particular article is down in the description. Check it out, and I hope to see you on the next one. All the same, stay smart as always and believe in yourselves.